Today, we are taking our understanding of physics to the next level. After mastering the units of fundamental quantities, it's time to explore derived quantities. But before then, we must learn how basic arithmetic operations like addition, subtraction, multiplication, and division help us create derived quantities. We'll cover the basics today, giving you a quick glimpse of how these operations work in physics. Don't worry, we would explore these operations more in our mathematics class. Let's get started with indices. You must have come across numbers like 10 to the power of 2, 3 to the power of 4, or 2 to the power of 5. In this case, 10, 3, 2 are called base numbers, while 2, 4, and 5 are called index or exponent. So we can say when it is 10 to the power of 4, the 10 is the base and 4 is the exponent. For the purpose of this class, we will refer to 2, 4, and 5 as exponents. There are 8 laws of indices. If you want to excel in physics and mathematics, you must have these laws by heart and be able to apply them offhand. Let's get started with the first law. The first law of indices is called the multiplication law. And it states that when multiplying two powers with the same base, add the exponents. For example, if you have a to the power of m times a to the power of n, the law says since the bases are the same, you pick one of the base and you add the exponents. Very simple. Now let's take numbers to do this example. If you have 2 to the power of 3 times 2 to the power of 4, the law says pick one of the base since they are the same, 2, then you say 3 plus 4, and this will give you 2 to the power of 7. This is called the multiplication law in the laws of indices. So we can try as many numbers as we can. 3 to the power of 2 times 3 to the power of 1. So we can say this is 3 to the power of 2 plus 1 to give you 3 to the power of 3. You can only perform this operation when the bases are the same. So if the bases are not the same, for example, you have 3 to the power of 2 times 4 to the power of 1, you cannot try this. Now let's go to the second law of indices. The second law of indices is also known as the division law, and it states that when dividing two powers with the same base, subtract the exponent. So this can be written as a to the power of m divided by a to the power of n. The law says when dividing two powers with the same base, subtract the exponent. So since the bases are the same, we pick one of the base and we subtract the exponents, m minus n. If you have 2 to the power of 6 divided by 2 to the power of 1, this will give you 2 to the power of 6 minus 1, provided that you are dividing and the bases are the same. And if you have 5 to the power of 6 divided by 5 to the power of 2, this will give you 5, 6 minus 2, and this will give you 5 to the power of 4. This one will give you 2 to the power of 5. So you can see, provided that the bases are the same, you can perform this operation. Now let's go to the third law of indices. It is called the power of a power law. It states when raising a power to another power, multiply the exponents in the brackets. Now let's take some examples. If you have something like a to the power of m enclosed in a bracket, then raised to the power of n, the law simply tells you that you should do a m times n. Very simple. Let's take numbers. If you have 2 to the power of 4 into bracket 2, the law says you should just 2 multiply the exponent 4 times 2, and this will give you 2 to the power of 8. Very simple. Now, what if you have 2a to the power of 2? It's still the same thing. You are to multiply this power outside the bracket by the power of every factor or by the power of every term in the bracket. So if you have, this is 2 raised to the power of 1, our answer becomes 2, 1 times 2, a 2 times 2. This dot means multiplication. That means these two, they are multiplying themselves. So this will give you 2 to the power of 2 dot a to the power of 4, which you can say this is 4a to the power of 4. So what did we do here? We use the power of everything inside the bracket to multiply the power outside the bracket. That is what this law tells us. The fourth law of indices is also known as the zero exponent law. That law states that any non-zero base raised to the power of 0 is equal to 1. So any number at all apart from 0 raised to the power of 0 is 1. A raised to the power of 0 is equal to 1, provided that A is not equal to 0. So a raised to the power of 0 is 1, provided that a is not equal to 0. So if you have 7 to the power of 0, it is 1. If you have 8 to the power of 0, it is 1. If you have 100 to the power of 0, it's 1. If you have 1000 to the power of 0, it's 1. That is what the fourth law of indices tells us, the zero exponent law. Any number at all apart from 0 raised to the power of 0 is 1. Now to the fifth law of indices, known as the negative exponent law. The law states that a negative exponent means taking the reciprocal of the base with a positive exponent. Take the reciprocal of the base with a positive exponent. Now, what is a reciprocal? If you have a number, for example, 6, the reciprocal of 6 is 1 over 6. If you have 8, the reciprocal of 8 is 1 all over 8. If you have 10, the reciprocal of 10 is 1 all over 10. So I believe you must have understood the concept of reciprocal. Now let's solve some examples. If you have, for example, a to the power of 1, this is the base, right? A is the base. The law tells us to take the reciprocal of the base, that means 1 all over a, with a positive exponent. This exponent here now become positive 1, no longer negative. That is simple, what the law is telling us. The reciprocal of the base with a positive exponent. So if you have a to the power of negative 2, take the reciprocal of the base, 1 all over a, then with a positive exponent to the power of 2. So this is as simple as anything. This is what the law tells us to do. Let's take numbers. If, for example, you have 5 to the power of minus 2, take the reciprocal of the base. The base is 5, so you take the reciprocal of 5. You have 1 over 5 with a positive exponent. So this is no longer negative. It will now be positive. Then we have 1 all over 5 times 5 to give you 1 all over 25. This is very simple. Now let us still see a twist here. If you have 1 all over 5 to the power of 2, you can easily change this to 5 to the power of negative 2. Again, 1 over 10 to the power of 3, we can say this is 10 to the power of minus 3. Do you get that? This is a little twist you just have to understand here. Now, if I say 1 to the power of a squared, this is also a to the power of negative 2, right? So you just understand this twist because you will need this when we start solving both dimensions and derivations of the derived units. Now let's go to the sixth law of indices. This law is called a fractional exponent law. It states that when a base is raised to the power of a fraction, the denominator will form the root and the numerator will form the power. Now let's write this. A, for example, to the power of m over n. The law tells us that the denominator, which is n, will form the root, and the numerator, which is m, will form the power. So that's it. If you have something like 16 raised to the power of 3 over 2, the law tells us that the 2, which is the denominator, will form the root. So this is already square root. There is no need of putting 2 here. So we have 16 to the power of 3. That is what the law tells us. And root 16, that means which number will you multiply 2 times to give you 16? That number is 4. 4 times 4 will give you 16. So you are multiplying 4 2 times to give you 16. So you have 4 to the power of 3. Now, the last law of indices. It is known as the root of a fraction law. It states that the root of a fraction can be expressed as the individual roots of the denominator and the numerator. If we have m over n in a root, we can express this fraction m over n as individual roots. That is what the law tells us. Now let's solve with numbers. If you have, for example, 9 all over 16 in a root, the law tells us that you can express this as their individual what? Roots. This is square root. So square root of 9 simply means which number will you multiply 2 times to give you 9, and that number is 3. And this one, square root of 16 means which number will you multiply 2 times to give you 16, and our answer is 4. So we have 3 over 4 here. Don't worry, when we get to our mathematics class, we will look at this comprehensively. We will go deep into these arithmetic operations. So for now, we are just having the superficial knowledge about that so that we can apply it in physics. Having studied the laws of indices, there is yet another mathematical operation students always find confusing, and that is minus times minus equal to plus, plus times plus equal to plus, minus times plus equal to minus, plus times minus equal to minus. Now let's group these operations. If we call this first two 1, and we call this last two 2. If you look at set 1, you observe that when you multiply the same sign, it will give you a plus. Minus times minus gave us a plus, plus times plus gave us a plus. So when you multiply the same sign, it will give you a plus sign. But then set 2, by observation, we can see that when you multiply different signs, it will always give you a negative sign. So minus times plus is negative, plus times plus is negative. So we can conclude that when we multiply same signs, it will always give a plus sign, and when we multiply different signs, it will always give a minus sign. So take note of this. Now let's play around this. If you are given this to solve minus 2, how will you solve this? Now, when you have two negative signs, like minus 2, just bring out the negative sign and you add the numbers. So this will give you, the minus is still there, 2 plus 2 will give you 4. Simple. If you have minus 4 minus 6, it's still the same thing. Bring out the negative sign and sum the two numbers up, and you have this minus sign will still remain here. 4 plus 6 will give you 10. That is very simple. Let's solve one more. Minus 3 minus 8. So bring out the negative sign and you sum the numbers, you add them up, and you have 3 plus 8 to give you minus 11. Now we know that 5 minus 4 is 1. Then what is 4 minus 5? It is minus 1. If 6 minus 2 is 4, 2 minus 6 is minus 4. When you subtract a large number from a small number, it will always yield a negative result. When you subtract a large number like 6 from a small number like 2, it will always yield a negative result. So have this in mind. What about minus 5 plus 8? Now, one thing you should note is that the plus sign is commutative. What do we mean by saying that the plus sign is commutative? You can interchange it and it will still mean the same thing. For example, 6 plus 3 is 9. If I interchange it, this plus sign, to 3 plus 6, it will still give me 9. Right? So that is the commutative power of the plus sign. 3 plus 2 is 5. If I interchange it to 2 plus 3, it will still give me 5. Now, having in mind that plus sign is commutative, anytime you see the plus sign between two numbers, you can interchange the number and it will still mean the same thing. So we can interchange it as 8 minus 5 to give us 3. So if you should see minus 10 plus 12, as far as you have a plus sign at the middle, you can interchange it to 12 minus 10 to give you 2. These are simple arithmetic operations that you're supposed to know. Lastly, let's learn how to express very small numbers and very large numbers in powers of 10. This is what we call the standard form in mathematics. Don't worry, we are having a superficial knowledge of all these concepts. In our mathematics class, we will look at them comprehensively and deeper. Now, in question 1, we can move this decimal point from the left to the right. And anytime you move the decimal point from the left to the right, you are dividing by 10 to the power of how many times you moved. Okay, let's take this for example. 1, 2, 3, 4, 5. So we moved 5 times and we dropped the decimal point between 2 and 8. So we have 2.8 divided by 10 to the number of times we moved, which is 5. This is what we're supposed to do. Now remember our law of indices. This can also be expressed as 2.8, yes, times 1 all over 10 to the power of 5. Yes, 2.8 times 1 will give you 2.8 over 10 to the power of 5. Now, when you have something like this, remember our law of indices, 2.8, you can now express 1 over 10 to the power of 5 as times 10 to the power of negative 5. Now, if you move a decimal point from right to left, you will multiply by 10 to the number of how many times you moved. So if we move this 1, 2, 3, 4, 5, 6. Now the point is between 2 and 8. We have 2.8 times 10 to the power of how many times did we move? 6 times. So far, we've treated the necessary arithmetic operations you need to know before diving into derived quantities and dimensions. So in our next class, we can now begin to apply these arithmetic operations. Thank you.